Given question, a roller of radius r is equal to 300 mm and weighing 2000 Newton is to be pulled over a curve of height 150 mm by applying a horizontal force F applied to the end of a string wound around the circumference of the roller. First, find the magnitude of force F required to start the roller move over the curve. Second, what is the least pull F through the center of the wheel to just turn the roller over the curve?
Let us understand the given diagram. Roller rests on the curve. It is in contact with the lower surface and it is in contact at point A where the corner of the curve. Horizontal force F is applied at point B where point B is on the circumference of the roller. Radius of the roller is given 300 mm and the corner point A is 150 mm from the lower surface. Now we will move to the first question. We have to find out the magnitude of horizontal force F when the roller start to turn over the curve. Now when the roller start to turn over the curve, its a contact with lower surface is getting lost and therefore there is no any reaction force with the lower surface we have to consider. Now we will consider the body is or the system is in equilibrium when the roller start to turn over the curve. Now in this situation the roller rests at point A and we have to find out the magnitude of force B. Now we will draw the free body diagram. Now here is the roller. We have to show the center point. Weight of the roller is also mentioned in the question and this weight will act in vertically downward direction and passing through the center. So we have to show the weight component, that is from this point O we will show here this weight W. Now point A is the corner point. Now in this situation the roller is in contact with this point A or it rests at the corner point A. So there is the reaction R. Now at point B, which is on the circumference of the roller, there is the horizontal force F is applied. So as per the given question we will also show here the horizontal force F which is passing through B. Now I will extend the weight W in the opposite direction. So if we observe, I will show this in the form of dash. So if we observe here, if this weight W is also passing through the point B. Now we know that the system is in equilibrium. That means the third reaction force should pass through the same point B because all the forces should be concurrent. That means they must pass through a single point when the system is in equilibrium. So this is the condition, that is the system is in equilibrium. So we have to draw the reaction at point A which must pass through B. So we have to show in this way. So here is the straight line and here is the reaction R. So reaction R from the surface on the roller. So direction is towards the roller. Now I will extend this R. We have to find out the angle made by this reaction R with the vertical line. So how to find out? So I will mark here this angle we have to find out. Now we will make here one construction. From this point A, I will draw one perpendicular line to the vertical line. So here from this point A, here is the vertical. Now here is the point C. Now we know that from this lower surface or this lower point, the distance is 150 mm. So this lower point, suppose I will say point P, then distance P to C is also equal to 150 millimeter. So I will mention here 150 millimeter. And I will also join this point A to the point O. Now here is the formation of triangle AOC. Now the distance from this O to P, that is nothing but the radius of roller O to P, is equal to 300 millimeter. Now we will find out this angle alpha, that is angle AOC. So how to find out? So we can write here cos of alpha is equal to OC divided by AO. Now O to A is also the radius of roller, that is 300 millimeter, and OC is nothing but the difference in between O to P and P to C, that is OP minus PC. So when we solve this, that is 300 minus 150 divided by 300. So here is 1 by 2, and therefore alpha is equal to 60 degree. So we get here the value of alpha 60 degree. Now we will concentrate on this triangle ABO. So here remaining angle, that is angle AOB, that is nothing but these two angles AOC and AOB are along the vertical line. So here remaining angle is 180 minus alpha. So 180 minus 60, that is equal to 120 degree. So this angle is 120 degree. Now we will make here the addition of all angles. Here is the triangle ABO. So addition of all angles is 180 degree, and if we observe these two angles OBA and BAO, these two angles are same, because here two lines, that is OA and OB, are nothing but the radius of rollers, and these two lines are equal in magnitude. So these two angles, so I will write here angle OBA is equal to angle BAO. So I will make the addition of all these three angles is equal to 180 degree, where one angle AOB is equal to 120 degree. So remaining angle, that is twice of ABO, is equal to 60 degree, and therefore this angle ABO is equal to 30 degree. So I will mention here this angle 30 degree. To find out the magnitude of force F, we will resolve this reaction force R. So here it's a vertical component, and here it's a horizontal component. So direction is in the same direction of the R. Now we know that with the vertical line, angle making is equal to 30 degrees. So we will mention here the same angle, because this vertical component and this vertical line are parallel lines, and this is the common line, because this is the straight line with the same inclination. Now how to find out its value? So for this vertical line, because it is nearby to angle 30 degree, we can say that its value is R cos of 30. And for this horizontal component, it is away from this angle 30, so its value is R sin of 30. Now for this system, we can say that summation of all vertical force is equal to 0. So which are the vertical force? So this vertical component weight W, which is equal to 2000 Newton, mentioned in the question, it is in the downward direction. So for downward direction, we will use negative sign, that is minus 2000. And this component R cos 30 is in the upward direction. So we will use here plus sign. So plus R cos 30 minus 2000 is equal to 0. And when we solve, R is equal to 2309.4 Newton. Now in the same way, summation of all horizontal forces is equal to 0. Now in this system, F direction is towards the left hand side, so we will use the positive sign, so plus F, and here R sin 30, direction is towards the right hand side, that is in the opposite direction, so we will use negative sign. F minus R sin 30 is equal to 0. Now we can put here the value of R, then F is equal to 1154.7 Newton. Now we will move to the second condition. We have to find out the least force F when this force F is passing through the center of roller. Now in this situation, when force F is applied and it is passing through the center of roller, then this roller try to turn over this curve and this contact with the lower surface lost. Now the weight of the roller is 2000 Newton, which will act in vertically downward direction passing through center. So we will show here weight W. Now force is applied in such a way that this force should pass through the center of the roller. So we will show here this force F, and I will extend this force F in backward direction. Now this system is in equilibrium. So all these three forces, that is the reaction at point A, this force F and this weight W, should pass through the same point. That means forces should be concurrent forces. So we have to show at point A the reaction R, it is also passed through the center point O. So I will show here, here is the reaction R and it must pass through the center O. So we have to join this R and O. Now we have to find out the magnitude of this force F. So first we will find out the angle theta made by this reaction R with this vertical line. So here is the angle. So I will say that this angle is alpha. If I make here one construction as I have made in the first condition, I will draw here one perpendicular line passing through point A on this vertical line. Here is the triangle AOC. Now this is the perpendicular line. So angle AOC, that is alpha, is equal to, so we can say that cos of alpha is equal to this OC divided by AO. Now what is this OC? Because A to C is perpendicular line, so the distance from the lower point P is 150 millimeter. This 150 millimeter and this whole distance from O to P is 300. So remaining distance O to C is 150 divided by 300. That is equal to half, and therefore alpha is equal to 60 degrees. Now we will resolve this reaction R as well as this force F. We will consider this force F is making an angle theta with this horizontal line. Now how to resolve? So here vertical component for this R, and here the same angle is 60 degree because this is the same line R, and this vertical component and this vertical line are parallel to each other. So here is 60 degree. Now horizontal component, now we will decide its value. So this vertical component is nearby to angle 60 degree. So its value is R cos of 60, and this horizontal component is away from the angle 60 degree. So here is R sin of 60. Now in the same way we will resolve this force F, horizontal component and vertical component. Now here the angle is theta, which is unknown, and we have to find out. So this horizontal component is nearby to angle theta. So F cos of theta, and here F sin of theta. Now summation of all horizontal forces is equal to 0. Now from diagram we can say that F cos theta, the direction is towards left hand side. So we will give here plus sign, and here R sin theta in opposite direction. So we will give here minus sign. Or we can say F cos theta is equal to R sin 60. And in the same way summation of all vertical forces is equal to 0. Now here direction is upward direction. So plus F sin theta, then R cos 60 is also having the upward direction. So plus R cos 60, and here is minus W is equal to 0. Now we will put the value of R because we have to find out the least force F. So we will replace this term R. So how to replace this term R? So here is the equation number 1. Now from this equation number 1 we can say that R is equal to F cos theta divided by sin 60. So if we replace this R with this, then we will get F sin theta plus F cos theta by sin 60 into cos of 60 as it is, which is equal to W. Now we will take F as a common term and this cos 60 by sin 60. So cos by sin is nothing but cot. So cot 60 into cos theta, here is sin theta, and this F as a common term we will transfer to the right hand side. So sin theta plus cot 60 into cos theta is equal to W by F. We have to find out the least force F we applied on the roller. So here is the equation. We will say this is the equation number 2. Now F is in the denominator. So for the least value of F, this whole term, that is W by F, should be maximum. And how to show this maximum value? Now if we observe this whole equation, then this term theta is unknown term and this equation varies with theta. So here differential value is theta to calculate the least value of F. And to show the maximum value of this whole term W by F, we have to show d by d theta. That is, we have to differentiate this d by d theta of W by F, which is equal to 0. Now when we differentiate this term with respect to theta, then we have to show is equal to 0. Then we will get this whole W by F maximum for that value of theta. So in the same way, because these two terms are equal, so we will show d by d theta in bracket sin theta plus cot 60 cos theta is equal to 0. Now we will differentiate. So sin theta means cos theta, cot 60 is constant term, so we will keep as it is, and cos theta is having differentiation minus sin theta is equal to 0. Now this cot 60 minus sin theta term we will transfer to the right hand side. So cos theta is equal to sin theta cot 60. Now sin theta I will transfer to the left hand side. So cos by sin is nothing but cot. So cot theta is equal to cot of 60. So theta is equal to 60 degree. So we can say that the angle made by this force F, which is passing through the center, is having an angle of 60 degree with this horizontal line. We will put the value of theta is equal to 60 degree in equation number 2 and we will find out the value of F. We will transfer this F to the left hand side and this whole term to the right hand side. So here is the equation. Now for this equation we will try to simplify this. So here theta is nothing but 60 degrees. So I will replace here with 60 and sin means here is also 60. Now I will multiply with this numerator and denominator with sin of 60, that is sin theta and sin theta, that is sin 60 divided by sin of 60. So here is the plus sign. So here also we have to multiply with sin of 60. So the term will become, now this cot 60 means what? That is cos 60 divided by sin of 60. Now here W sin 60 divided by sin 60 into sin 60, that is sin square 60 plus. Now here sin 60 and this sin 60 is getting cancelled. And this remaining is cos 60 multiplied by cos 60, that is cos square 60. So we can say that W sin 60 divided by sin square 60 plus cos square 60. So we know that sin square theta plus cos square theta is nothing but it is equal to 1. So remaining term is only 2000 sin of 60 because W is equal to 2000 Newton. So when we solve this we will get 1732 Newton.